morning. It's great to be here. Thanks for having me. A little correction on the name. It's Charles Lane. Nobody wants to say Lane. So I'm not sure what happened to my presentation. But I've been in the oil and gas industry for 37 years. I work for Pioneer Natural Resources. As you can see, I have a tough act after me, so I know you're not here to see me do a presentation, but to see the robots. I am not a cybersecurity guy, so this conference is a little chilling for me because I'm a SCADA guy. I'm not an analytics person. We're trying to learn that now. So keep that in mind as I present. But we are doing some pretty exciting things in the realm of analytics with our SCADA data. So Pioneer is a large independent oil and gas company based out of Irving, Texas. We focus in on these four basins. Our real core asset these days is the Permian Basin, where we have over 800,000 acres that we lease, and we have 20,000 prospective wells that we plan on drilling. Pioneer, since 2009, has made the top 3 places to work in the DFW area with the large companies. And we like to think that we can compete with Google. I've heard several people say that they can't compete with Google, but I really believe that Pioneer can. So if you're interested in working for a great company, you need to drive to Irving and visit us. So a little bit set the stage for the analytics piece of this. 4 years ago or so, we started replacing our HMI, our SCADA system, with Ignition. We felt like it was a modern platform that would take us in the direction that we wanted to go. We've completed 5 of the 11 system conversions. Currently, we have 2 million tags in our system, and when we finish those conversions, we'll have 10 million tags. We have 29,000 devices on our network. That's a mix of EFMs and PLCs. We have 124 Ignition data loggers, and basically what that is we put some industrial PCs running Linux at our wellheads where we record sub-second data on downhole gauges, and then we use SQL Sync to bring that back to our Las Colinas office. We're logging 52 million records a day, retrieving 160 million records a day. In the system, we have 442 active clients, and during the 8-hour period, we average 90 folks on the system. Our new wells and facilities will yield another 10 million tags over the next 9 years. So when deploying analytics, things that you may want to consider is time to implement. We've been working on another analytics project where we're putting a high-powered server out in the field near one of our. It's basically at a tower location, and so we put that out there almost a year ago. We spent a couple $100,000, and we really so far have yielded zero on that. Some of that is because we just haven't had the resources. Other things, it took us 4 months to appropriate the server and another couple of months to load the appropriate software on it. But, so if you really want to get good results and things, you need to think about the time that it takes to implement. Longevity of the technology. A lot of the technology seems like it's changing every day, and so you may want to consider that. A big enterprise, I think enterprise, because I'm an enterprise SCADA person. But sometimes deploying enterprise type technology takes a long time. It's a little bit cumbersome. So you might think about some of these technologies are going to be changing quite a bit over the coming years, and you may want to look at things that I guess what I would say is you may want to look at things a little bit different because things are going to be changing so quickly. Organizational alignment, it's always great to find that champion and involve the subject matter experts in the field. Again, I was talking about these enterprise type systems where you have a single platform, mega size companies that may help you. That may be appropriate at some point, but some of these small multi-platform adoptions may be a better answer in the beginning as we progress through this technology change in the industry. Our objectives are to provide tools for everyone. We have 3,600 employees. We really want to put these tools in everyone's hands. They have different needs and different requests, but definitely want to put these analytical tools in everyone's hands and serve analytics to untapped customers. And then we've looked at this product that I'm going to talk about, Seek, as our first line of insight into the processes that we have. And then we may want to do machine learning on the edge where we're actually controlling wells and compressors and things like that. But the tool that we're using today for that first line insight is Seek. So a little bit about self-serving analytics and the Seek platform. It ties into our Ignition platform seamlessly. Basically, we did a proof of concept over a 4-month period, and within 4 hours, we were doing analytics on that data. It's very impressive, and most of that time was really the indexing of the data. We had instant insight into our data, super easy to use. We've got 5 or 6 engineers and some non-engineer analysts using the system. It's got some great tools, right? So pattern search, prediction regression, and it's really big data innovation the way that it works. We actually don't have a historian per se. We're using SQL. Right now we feel like SQL serves us well, and so we're at some point we'll probably have a data historian, but we feel like SQL serves us well right now. And one of the things that, as a manager, that excites me about this tool is that it's got a great journal in it. So every step along the way, you can journalize how you got the answer, and you can present that to the people that are going to have questions. So you don't spend hours and hours and days building a model and then not really being able to show people how you got there. It's very intuitive. You can show them right away. And so you come up with an analysis. You can send out a link to that site to a user that maybe never used Seek, but they can get that URL and go right to the product, or you can publish it in PDFs or PowerPoint. It's really great. It makes putting together presentations really easy. So I want to talk to you a little bit about a use case that we have on some gas lift compression. How many of you in the audience here are from the oil and gas industry? So a couple of you. So gas lift basically is a form of artificial lift to produce our wells after they get to a certain point in their life where they don't necessarily easily give up their oil and gas. And so what we do is we pump gas into the well bore, and it lifts the fluid, and that keeps our returns coming. And so So far, we have 120 gas lift compressors. It's got 150,000 horsepower out there. Each one of those compressors move 4 to 6 million cubic feet a day. And that's about 2/3 of our production in the Permian Basin. So we're currently producing 300,000 BOE a day of oil. And so 200,000 or so of that is on compression. So compression is very important to us. We depend on it. So we've got about a 98% runtime. So our challenge is that determining these abnormal operating conditions across those 120 or so compressors, identifying conditions of interest. Our maintenance department, in the case that I'm going to show you, we saw where in our downtime tracker, where over a 2-week period, they had to replace 4 or 5 parts. Some of them were related. You could correlate what they replaced by the data that they were seeing or the information they were seeing at the site. But some of them were kind of out there. You'd wonder why they replaced them. And then, as you can see, ignition is a great tool, and you can trend the data for the site, but you really don't have a whole lot of correlation there unless it's just really, really evident. So the solution was to have a correlation of the signal data. We wanted to define those conditions of interest using a capsule for every site. So once the system identifies an area of interest, it creates a capsule, and you can use those capsules in many ways to pinpoint your interest and your investigation. And so, you start using these analytical tools, and so if you live in the ivory tower in Irving, Texas, and you call Midland and you tell them they got a problem, they're not all that receptive unless you've got some proof. And so we want to make sure that we got proof. So here you can see in this screenshot of Seek, you can see that in this event, the engine load is in orange, and our temperature on cylinder 9 there is in blue. And you would see a big increase in our cylinder temperature with a sharp decrease in it. And so this went on for, like I say, almost a month, several weeks of replacing parts, and we had downtime. And basically, a week or so after we installed Seek, one of our compressor subject matter experts started using the tool, and within hours, he saw these anomalies. And so he started investigating, and he went back in our downtime tracker. He saw where people were replacing parts, and immediately he recognized that we had a head problem on the compressor. And so he went back in time, and we could see several of the incidents happening. And so he was able to put the data together, send it out to the field, and basically we came up with a plan. And so you can see here in this picture where we had a bad valve in the head. And so we got a plan together that day. The next day, went out and replaced the head on this compressor. And we saved a cylinder, a piston, and a turbo. So if we would have lost the piston and shelled it, we would have, the turbo on those compressors are $20,000 a piece. So we easily saved $20,000. But not only that, we had a plan. We were able to do a planned shutdown of the compressor, pull our other compressors up to higher level, and not lose any production. So it really paid off, and we've got several other groups of people using it for different things just in a very short period of time. And these analytics really are showing their value. So the results where we identified a condition before failure, our maintenance solved issues with minimal effort. So we feel like we saved probably $30,000 in repairs, and our production loss was minimized. So we like to say that we nailed it, right? So we're really excited about this. And just in just a short period of time, you know, we didn't put in a big system. We didn't spend months and months doing this. This happened over a couple of week period. So it works really well. And it can work with other things other than ignition. And Brian can tell you about those at some point. One of the things that we're doing to take this a step further is that we want to create these dashboard type deals. They call it an asset view. And basically, an operator of the compressor, a lease operator, a guy that takes care of his wells, a production foreman, can go out and he can see these red squares and he can click on those and it'll take him right into his problem areas. So report by exception for this compressor fleet is what we're working on now, kind of in the middle of that. So, you know, we've got this 120 sites. We don't have to dig through the analysis on every one of those every day. So we want to create an efficient workflow with this long investigation cycles. Our solution here is to use this asset structure that SEEK has to produce and I say report here, but it's not really a report. It's information. And we want to auto-populate. They call them a worksheet for daily visualization. And it allows you to do data investigation. And it's not a report because it's really interactive. So our results are this daily report created for decision making. Our engineers can prioritize tasks based on the analysis, and we can increase our oil and gas production. So here you see that here's an event that's created about 7 incidents that allows us to email these results out to the individuals who have issues. They can click on those little, I guess, seven worksheets over there that allows them to dig right into this interactive data that allows them to do their analysis themselves. So we nailed it in the beginning, and then we're scaling it. So it allows us to have an efficient workflow. So our benefits to this system has been that we can expedite our ad hoc investigation, enable our subject matter experts, and we really feel like that, you know, that we don't need a room full of data scientists for this particular tool to be useful. And it doesn't have to necessarily be an engineer, although we have lots of engineers, but we have lots of engineering analysts, field operations folks that can use the tool very easily. And we've got this predictive asset models for use, and this collaboration and publishing is a great tool. So that's my presentation, and I thank you very much for your time.